Good morning. Now in this video we'll see about the difference between boiling and evaporation. I'm sure you all know what is condensation, melting, freezing, but then there you have to mention about there is no change in temperature and so on. But today we'll mainly focus on what is the difference in terms of molecular movement in boiling and evaporation. Now both actually, what are the similarities here? Both processes involve the change of state from liquid to gas, right? Both refer to change of state from liquid to gas, but then how are they different? Let's see. Now when does boiling occur? You heat a liquid to its boiling point if it is water. So when it reaches to 100 degrees Celsius, all these molecules will have the same amount of energy or same kinetic energy, and then they have the chance of escaping the liquid and they convert into steam. So here temperature and kinetic energy, that's a key term here. Temperature and average kinetic energy of the substances, how are they related? Direct proportion. So average kinetic energy is directly proportional to temperature of the liquid. This is important. That's what you have to remember, right? So here all these molecules have same or the average kinetic energy of all these molecules are the same, so they have equal chances to escape the liquid when they reach 100 degrees Celsius. How about evaporation? Evaporation is like you're not supplying any heat energy. This you may have observed in your daily lives. We just leave it open in a table or so, there is liquid. After some time when you notice, the liquid's temperature would have dropped. Now the reason for it is what we are going to see. Now since it's at room temperature, say if it is at 30 or 40 degrees Celsius, that is irrelevant. Now here what happens to these molecules? Will they all be at the same energy level? No, if you take each individual molecule, they might have differences of energy level. Some of them might have more energy than the rest. So a few of the molecules, when they reach to the surface of the liquid, so imagine there are two molecules which are having greater energy than the rest, and when this comes to the surface and it possesses enough energy to escape into this atmosphere. I say here escape, yes. Why do I say? Because what is holding the molecules inside? There is a molecular force of attraction between the molecules inside the liquid, right? That's why they all stay within the volume of space. Now when they come to the surface, and if they possess enough energy to break all these bonds and escape to the surface or escape in the atmosphere, they can let themselves free, right? So not all molecules will have these chances, but then a few molecules which have enough energy to overcome force of attraction. This is important. Now this is the key term here. So those few molecules, when they come to the surface and if they have enough energy to overcome the force of attraction from the rest of the molecules, they can escape into the atmosphere. Now here above also there will be, that I'll come to later, what will be the force that is pushing it down? You have an atmospheric air pressure that also will be pushing it down. So if that's greater, it will need more energy and so on. Alright. Now how does this cause cooling? Now earlier, say including this, if you take the average energy of the molecules, just as a rough estimation I'm giving, say 50 joules. Now since two energetic molecules have escaped, this 50 joules may have dropped to say 45 joules of energy. So the average kinetic energy of the liquid has now dropped, decreased. So what will happen to the temperature? Naturally the temperature also will be lower than before. Alright, so here what has happened? Evaporation has happened. When does evaporation occur? It can occur at any temperature, but then will all the molecules escape, or do all the molecules have equal chances to escape from the liquid? No. A few molecules which have enough energy will escape. When they escape, the average remaining liquid will have lower average kinetic energy, which is proportional to the temperature, which drops. Hence, evaporation will cause cooling. Getting it? But will boiling cause cooling? No, all of them are at the same temperature. Every single molecule has got the same possibility of or probability of escaping the liquid. I hope it's clear now. I'll see you in another video.